Hey everybody, this is Larry. This is me doing week one of the weekly premium November challenge. Oh, apparently I've done this before. It is a hard problem. I don't know. I'm not gonna lie. Anyway, all right, week one of the November weekly day challenge or weekly challenge. Hit the like button, subscribe, and join me in Discord. Let me know what you think about today's problem. Not gonna lie, usually I'm more detailed about this. So if you're watching this, if this is your first video or new video, my apologies, but this is probably not gonna be that long. And just the reason is just because I have a marathon tomorrow, so or not tomorrow, but like a day and a half in a day and a half. So I'm just gonna watch this so that I could rest. I'm trying to like spend all tomorrow in bed or whatever, except to get food and just eat a lot and keep eating. So in any case, I'm gonna, yeah. We already done it before, and apparently it's even in memory from like 2 years ago with the wrong answer. So watch that video if you really if this video is not good enough for you. Watch that video and let me know in the comments. But yeah, all right, let's take a look at today's problem. Let's actually solve this though before I say that I'm gonna solve it quickly. Maybe it will end up taking me a long time anyway. Okay, so you have a matrix. It has a width and a height, and each cell is 0 and 1, and any square submatrix of live sing. And any square submatrix X has at most right? What does that even mean? They give you side length. Oh, this is a constructive problem. I misunderstood. I thought they were giving us. I didn't look at the input because they don't just like consider. So okay, so basically you have to construct one where this is the case. This seems pretty greedy, right? Let's see. In some way. So basically we're saying that for every square, we have some width times height matrix. For every square, we have to have at most ones, right? So we could probably just like think of it as a pattern. I think this makes sense, right? And we don't want to maximize the number of ones because then now, let's say we have without loss of generality, we have some L by L, right? And then if we have L by L, then I don't know, maybe these should be dots. Let's just say this is L, right? Then in a greedy way, you always want things to have two properties. One is near the top and also to the left, right? And this is greedy just because then now in a almost like a bin packing kind of way, in a bin packing kind of way, that just makes sense, right? Because the more left it is, then now you have more space to pack more on the left. I mean, of course, if you could also scan the other direction and say that to the right, but without loss generality. So that's the first observation. The second observation is that now, how are we? I think there is some stuff about width and height not being the same, right? But honestly, I think. And I think this is a catcher, but I think it doesn't really matter, right? Because or like within. Oh, actually, maybe I'm wrong. No. Maybe that's fine, right? But basically, the idea is that you have to have the same pattern, right? Because for example, if you let's say max ones is equal to 5, if you have some like weird pattern where like you have this, and this is a little bit weird, but then now. You have to kind of like go to the if you have a different pattern then actually I don't know what I'm doing SQL. Let me draw it out. Hang on. But I don't think this is a tough problem. So maybe I will get my wish of calling this early, right? But what I was saying is that okay, so then now if you have something like maybe I don't want to draw the grid. I'm too lazy. Like, let's say you have this, right? And if it's not regular, then you have to do more math because if you look at something like this, well, yeah, maybe this has 4 things, but then next to it, if you do like a sliding window, so it's every x by x, this has more than 4, right? So the greedy, but the thing with this is the I think this is like tiling theory, right? I'm not going to get into it too deeply, but if you have something like this, it actually doesn't actually matter what the pattern is for the most part ish, right? If everything is even out, right? The only thing that matters is that the greediness with the upper and the left, right? Because you could do something like this, but then if you have one more, then actually I guess this is still fine. But let's say you have two more lines, then if you draw a pattern, you have 4 by 4, 4 by 4 still good, 4 by 4 still good, but this does not maximize, right? It doesn't maximize because you can have, instead of these two, you can have them here, which means that these two would be good, and then you have more ones, right? So that's kind of the idea. And then the other thing with tiling is that if you have a pattern, then this sliding window invariant always holds if the pattern is the same. So given these two things, and then now the third thing is that width and height is not the same, right? If width and height is not the same, you just have to, just generate an example. But this is basically also greedy. And what I mean by that is, let's say you have, I don't know, 2 by 10. Oops. 2 by 10 as a very dramatically different one, right? And then now obviously you have a 2 by 2 thing where you can max. Well, I guess in this case maybe it doesn't actually matter. Well, I mean, I'll give you a counter example, but and maybe let's just say 2 by 9, right? Maybe that's a little bit more easier. But when you have something like this where you don't optimize for the greediness, okay, actually let me use a different example. Sorry, I'm doing this live after all. But let's say 3 by 12 or something like that, right? And let's say your thing is by 3 by 3, right? So that means you have 3 by 3. And of course, and let's just say max is equal to 3. Then now there are two ways to do it, right? Or there are multiple ways of doing it, but you could do it like this, for example. You can do it like this, for example, right? But the idea here is that we take the long end and where do we want to go, right? It's so that, and well, this is divisible by 10, so let's just call it 10. Right, so this is 3 by 10, and 3 by 10 means that you have 3 full ones and a 1/3, right? So that means that if you chose the black ones, you may go something like this, and if you just tile it lazily, then you have this, which only has 1, right? But then if you do, if you're careful and do it this way, then now you have all 3, right? So then now this has 12 instead of 10 or something like that. So that's kind of the idea there. And for this problem, you actually do not have to draw it. So you don't even have to but you still should draw it for visualization if you don't understand it and kind of get the ideas, right? Okay, so then now, that means that for every, I'm going to just change this to L. It's easier to type. For every L by L, there are max ones. So then how many full L by L's are there, right? Yeah, this is kind of annoying, right? Well, this part is not, but I'm just saying. So full is equal to width times height, right? Okay, so there's this. So yeah, full times max ones is a total is equal to this for now, right? So that's the total. So then now we have to think about how to handle the leftovers, right? How do I want to think about it? I think if we're doing just the math, right? You have something like this. I mean, these are hundreds, so you can actually simulate this if you want, but I'm just trying to do it more mathematically. And the idea then now is that they're really, if you want to draw it out, and let's say you have boxes, right? Then now you only have quote unquote the leftovers, right? There's the bottom leftovers, and then the top leftovers, and then the overlap leftovers, and we have to basically figure out how to do the math and how to fit it in, right? How would we do it? That's actually because you still want to keep the pattern, the same pattern for all the boxes, and now we're just hanging out leftovers. I guess here you can, and suppose there's, I mean, it's gonna be with mod L, right? So that's like the number of things here. So we can just we can just do the math of okay. So basically the idea is that, okay, we have max ones, right? So that's how many things that we want to put into here, right? Into this box. And this box, we can calculate how many things we can put in here. And if we put it here, then this is the contribution is up to here. And then this contribution is here, right? So we can do the math in that way and then choose whichever gives us the most, right? Meaning that we fill this, and then if we fill this, or we do it. And keep in mind that you could do both. It's just that you have to do it in order, right? So either we do this first and then this, or this first and then this, right? And then after that, we just maybe do the math on here as well, and that should be good. And here, I think there should be no issue because it'll be dominated by these number calculations. Okay, so then now we say, I don't know, bottom first. So bottom first, that means we have height mod L, right, as the spillover. So this is going to be the height times width, because that's how many. Okay, actually, okay. So this is the height, and then, oh, that's how many height cells times width. That's how many per, right? That's how many that we can fit on the max ones, right? Man, this is actually kind of annoying. I mean, it's not hard, but it's annoying. Because basically you're saying that, okay, this is the leftover in height, we have the width, and we're bounded by max ones, right? So so maybe this is the bottom is equal to this. So this is for each one, and how many numbers are there? There's going to be width the number of these. So it's going to be bottom first is equal to bottom cells. So maybe this is bottom cells. So we have bottom cells times the count. But this number is also bounded by max ones, right? So we want this to be min of either this or max ones, right? Because that's the most you can fit. And then and yeah, and that's fine. Well, yeah. So it's this, and then now whatever's left over, right? Which is going to be okay. So then now right cells is equal to min of width, because then that's the leftover, times height, right? So that's for one box, and it's either this or max ones minus bottom cells, right? Because we already used them, because this is the bottom first one. I don't think I'm explaining this well at all. I don't even know if I'm right. So yeah. So then now it's gonna be bottom cells. We count the number of bottom cells plus the number of right cells times the number of them, or number of right cells and the number of right bigger cells, if you will. And that's the bottom first. And then now we want to do right first. So then bottom cells in this case comes after right cells, because we're doing right cells first. And it's basically the same thing except for that. And maybe you could generalize this in a for loop if you like, but this is basically the idea, right? And now you have right first is equal to the same idea, which is the number of cells we have and the number of big cells plus bottom cells times with right? Keep in mind that I have not forgotten the extra, the overlap, right? Yeah, That's why this is divided down. And then the overlap, it is just width. So overlap is equal to width mod L times height mod L, right? And then this will, and this will always be less than either right cells or bottom cells, so we don't have to worry, because that's the definition of overlap. And because, you know, the size of it will be smaller, because this is multiplying by, instead of multiplying by height, which is the number of big ones with height, this is just the extra ones, right? So then this is the overlap, but we want to still min by max ones and this one, and then now it is going to be total plus either max or bottom first, right first, plus overlap. I don't, this doesn't feel good, and you know. All right, well, at least we tried. All right, let's take a look. We have total, we have bottom first, right first, overlap, right? So this is 3 by 2, 3 by 3, 2 by 2. This is probably optimal. Okay, so let's say we have total. We have only one full total, so that's 1. That's actually what we expect. Bottom first. I mean, both bottom first and right first should be 2 because we have 1 left over. So we can take a look. So bottom cell, it's going to be equal to 3. So this is 1 times is width, right? Width is wrong. This is not width. Why is this width? No, this is width. This is times. It's not width. It is times L because I want it to be in terms of L, right? So that's why this is wrong. Because it is saying that what it is saying is that it's overlapping, but then each of these chunks have a length of L, right? So it should be L. Okay. And the same thing for this. So I think this is more accurate. Still wrong though. And it's still giving me 1 here. All right, well, let's take a look. So this is going to give me 1 times 1, which is fine, and then min of 1. Oh, so then it's going to be 1. Huh. I am... I know what I'm doing wrong, but I have to try to think about how do we solve it. So what I'm doing wrong is that I go, okay, well, let's throw the bottom first, and then we throw the top down, right? But the thing is that these things are actually the same pattern, so they do not share the max 1, which is what the idea I have here. I think we can also simulate if we really have to be honest. I'm trying to do this mathematically, as you can see, but no. So I think what we want then is the overlap. Actually, the overlap, because this is so hard to visualize. I mean, I'll show you because I actually see it now, but I feel like I don't have the vocabulary to express it. But basically, yeah. So looking at the bottom half for now, so we have this overlap, right? But what we're also saying is that the reason I undercount is because whatever, you know, let's choose another color, Larry. Let's say you have blue is terrible. Okay, so this is right. So let's say you have like this thing, it overlaps with this thing. So I was trying to go like, okay, well, let's maximize throwing out here because it gets cut off. But then I just forgot about this overlap. But this overlap actually also turns out to be this thing. So we should calculate this first, is what my point is. And then we could fill out the rest in a prioritized manner. So then now we go right? So we always want to do the overlap because it gets used everywhere, right? So then now we say max ones minus overlap. And then now we do it this way. But it's still a little bit off because we have to count the overlap. So we'll have to think about how we think about it. But okay, so we do by themselves. This is the number of things. Kind of. The kind of is because it is this plus the overlap for each one. And this as well, right? Yeah. Honestly, I'm not super confident. But it makes sense. But I could... It is an improvement, and I think this is a little bit better. But I don't know that it is sufficient. I guess that's what I wanted to say. Okay, well, this is just not right. But, okay, overlap should be 1, right? So let's see. Oops. Oh, yeah, overlap is 1 here. So then now, what is bottom cells then? I will bottom first. So bottom cell, this is going to be 1. And then, so this should be 2 on the bottom cell for each box. So what is going on? All right, let's print it out. Okay, so right cells is definitely not right. But it has overlap, so why? Height, is this part right? Width divided by L. Height divided by L. This seems right. Why am I getting... Oh, no. Right bottom first is 1. But right cells is wrong. So this is 1. This should be 1. Maybe it's this part. I guess this is... because overlap is 1. So this is returning -1. Oh, I see. Because this is already overlap. But then this is the extra 1. Right, so max 1 already doesn't count the overlap. And then this one also don't count the overlap as -1 because we ran out. So this has to be max of 0 maybe. And that means that, I mean, I'm going to run it, but we have to do it here too. Okay. I mean, now that makes sense. It is just a lot of case analysis. If it looks like magic, it's just because there's a lot of case analysis. Basically, well, okay. I was going to explain it, but then I was like, actually, let me submit it first because if it's wrong, then there's no point of explaining it. But why am I wrong? I don't know. Oh, wow. All right. Well, we can actually try something a little bit more obvious as well, which is say we have 3 3 2 2. We have just basically a 4 1. Is the 4 1 going to give me trouble? X is out range. Did I miss a number? I don't know. 3 3 2 2. Oh no, it's not 2 2. It's just 2. This is 2 by 2. Okay, so it works for this one, but not this one. But honestly, the way that I'm doing it is by case analysis, and just try to figure out, right? And that idea is just that if we have something like this, then now in a greedy way we go, okay, well, if we prioritize putting the ones here, then we would have X number extra. And then now we do it here first, right? And it could have multiple columns or whatever. But I'm surprised that it failed. I mean, maybe not that surprised, to be honest. Let's see, bottom cells. So that's the contribution of each thing times this. We only have one extra box of overlap. That seems right. All right, let's just print it out real quick. Overlap is 8. Does that make sense? What is that? I mean, it's 4 by 2 extra overlap space, so 8 makes sense. What? But I'm getting also higher, so that means that something is really wrong, right? But the bottom first or right first has the same number, so it's not that. It's not total either. Oh, I mean, it could be that, but it's not. I mean, it must be that because total is just trivial, I think. Oh, unless, no. Yeah, I was like, maybe max ones can be bigger than that. That's the part that I know I didn't implement. That's for sure. Maybe we could just draw it out. I don't want to draw it out. But the bottom first part makes sense, or like it makes sense that this would be the wrong thing. But so okay, so let's draw it out then, right? So here now we have actual numbers that we can use to play around. So then now we can say okay, so we have dot, oops, we have dot, right? So then now we have, for this one we have 74 by 52. So that means that we have, which one is first? Oh, width is 74. So that means that we have length of 4 here, and then length of 2 here, right? And then the overlap is 8, right? So here we have 8. Let's just put in number 8. And that means that for each one, we want, oh, I see. I think I see why. I know a case in which I did not handle, which is that here. No, is that right? No, I think maybe I did handle it actually. No. This is wrong because I did not. I add overlap, which is fine, but I have to get away from. This has to subtract by overlap. Max 1 is fine, but this one has to subtract by overlap because that's the max space that we have per cell, not including the overlap. So okay, so that's the hard part about case analysis. Sometimes is that, well, you just missed a case, right? As you can see. Yeah, okay. I didn't really think it through that much, and as you can see, it works now. Hopefully this is it. Am I confident? Maybe a little bit more than before, but still not 100%. Now we're undercounting. It's probably the overlap, actually. Yeah, it's probably the overlap. Is it? I don't know. If I guess it, the reason why I think this is probably the overlap, because we're subtracting the overlap, so maybe there's some like weird thing here. If I have to guess, it is because this is bounded by. No, overlap should already have things, right? So then now, wait, am I showing you the? Oh, sorry, I'm blocking the wheel. Well, I mean, you didn't miss much. I still got a wrong answer. I guess that's the TLDR. But I basically added this code to subtract overlap because if you look at each cell and we took out the overlap because we always guaranteed overlap, then we don't have it, right? I think the thing that I'm a little bit concerned about is just this part where if it's max, if we took the min of max ones, then this is the overlap. Maybe we took away too much overlap, so then this gets messed up. Or no, this can't be greater than 0 by definition, because it's this number, and this number will always be less than L. So that doesn't make sense. Maybe, I don't know. Let's just put it out. I mean, the numbers don't have like crazy like -1 things for me, so at least that's good. Like, I mean, well, I mean, it's bad in, I mean, it's good in that that's not why I'm wrong. It's bad because if that was why, then it's an easy fix. Or, you know, easier to dig into. But nothing very basically wrong. I can tell. Maybe I should have just simulated and made this video quicker, because now it's half an hour, even though I wanted to rush it a little bit, and it's getting late. Do I really want to do the math? I guess we do. So then now, okay, fine. Let's bring back the thing. Sometimes it is what it is. I don't want to do it because I'm lazy, but okay. So then now this one you have 68 by 86. L is you go to 63. So then now you have 5 by 63 at the bottom, and then 23, 68 by 23. Wait, is that true? No, wait. No, this is 63. Oops. That's why I mean, it is definitely a no, but that's why it's a no. 63 by 23, right? Is that right so far? Just want to double check. I think so. Because L cannot be. Yeah, okay. Just want to make sure that's the reasoning. Okay. So then now, when what is our max one? The max one is 1474, which is a big number actually. Okay, so that means that the overlap is going to be 5 by 23, which is equal to 115, I think, right? Okay, so that means that 115 is filled up. So I'm looking at the standard output here as well. So what is our max thing again? Oh, is this thing? Oh, what does it say? So, okay, so then we do bottom first. If we do bottom first, we have, this is the bottom cell, right cell. This is bottom cells is not right. Am I doing overlap wrong? No, overlap is 115. But no. Bottom cell is height. Mod L. Oh, I guess this one. I think I confused myself. Well, bottom first should be 5 times 63, right? Cell, and I think I mixed it up, maybe. Huh. Bottom cells is 1449. Alright, I'm going to put it in a calculator. I think it's 63 times 23 is 40. So I definitely do here. I think I just wrote it wrong, to be honest, so it's fine. Okay, so you have 1449. So you use all of it, right? So overlap is 115, we have 1474. So that means that how many do we have left for this one? Let's see. So we have 115 for 5 of these rows, right? So that means that we have 58 by 23 that we used up. Okay, so that means that we have 1474. Okay, so but this is 5 by 40 because the overlap is this stuff, right? So 5 by 40, that's 200. The reason I am a little bit confused is this definitely does not feel right. Because I'm just looking at the standard out here. The bottom cell 1449 is max, that's fine. Overlap is 115, which is not this number, by the way. This number is the other cell, which is the 5 by 40 part. But that doesn't seem right. I feel like I'm missing something. So that's what I'm looking at here. Okay, so this is 1449, but we used up 115, and we used up this number minus 115, but then it all ends up being 1449, right? So 1474 minus this is equal to 25, right? 25 plus 115 should be right, because this means that we have 115 is just the overlap, right? But then we have 25 on the other one, and that actually is the exact number that we're missing by on the output. So I think our logic is right, but our math is wrong. So the right cells, this logic is wrong. So max ones minus bottom cells. No, I see. Because bottom cells already took account overlap. Because bottom cells we add overlap. So then this means that this counted twice or something. So we actually need to plus overlap here. Because max ones we subtract overlap. Bottom cells we also subtract and then add it back in. So that's why it doubles. Okay, so that's why. But like I said, case analysis is tough. We also have to do it here, by the way. But yeah, case analysis is very tough because it's very easy to, or at least for me, I mean, it may not be for you, very easy to make these mistakes, you know, in double counting and so forth. Hopefully this is right so then I can go home and sleep. I mean, I am home, but, and it is right. So I mean, I think the idea we were good, and the idea really is just breaking it to all the different cases. Honestly, if I were to do it again and I was a little bit less arrogant and I was a little bit less rushy, I would probably make these statements more explicit. And what I mean by that, instead of having min and max and stuff like that, I would just have more if statements, and that would express what I want to do more. You know, instead of prematurely optimizing. And honestly, this code looks like really messy and really not that readable, right? If you kind of jumped in the middle. I hope it makes sense, but not if you weren't already prepared for it. I'm curious what I did 2 years ago. I guess I did this. I mean, I guess I did the same thing, except for I did it correctly. I suppose one time more. It looks basically the same. There's some but I don't know. Maybe you could watch that one instead. But this one works today as well. Yeah, I mean, this one's fine. I think maybe doing it here was a mistake because it kind of made everything else a lot more confusing. But I don't know. Maybe it's fine. Let me know what you think. I mean, this is all. Oh, I actually forgot to take this one out, so we can even get it maybe. Oh, I guess it was already at 100%, so maybe it doesn't matter. But obviously this is all of one, right? Like it's just all min, max, multiplication, division, stuff like that. And yeah, look, my mouth is dry. I need to use the restroom, so I'm gonna call it a night. I'm tired, and just like pick out. Thanks for watching, everybody. Thanks for the support. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.